Alrighty, everybody. Happy Monday. I hope you guys had a good break. I am obviously not in the building today. I will send you the link to this. Well, if you're listening to this, then you got the link, right? We're going to talk about Chapter 33 AECs. What I would, obviously want you to do is to follow along with this, make some notes. If you happen to do a little outside reading, that might not hurt, just because this information is somewhat abstract. I need you to get it, to understand it, because you are already using the automatic exposure controls, or what we call photo timing. That's almost always the euphemism that RadTech will use when it comes to talking about this. Now, I will tell you that AEC is great, or photo timing, and that's probably what I'm going to call it. Photo timing is great, and most of our photo timers these days use something called an ionization chamber. And so we're going to talk about that. You can see when it was invented there. That's interesting. Whatever. Um, what the AEC does is it takes away your need to select the time in essentially the mass. You think about it. When you're the technologist, when you're setting a technique, you're trying to determine what the KV is, and we've talked about that. Again, over and over, I say this: you need to have certain KV ranges that you're going to use for particular parts. You guys have heard that out of my mouth enough to where I'm not going to go through that again. But make sure you know what KV range is for what parts. And then the next thing you select is the mass. In our lab, because we don't have photo timers, in our lab, that means it's a manual technique. And so you guys have gotten somewhat used to setting techniques for this, that, and the other thing, the mass for this. Photo timers, as you well know, take that away from you, that requirement to say, well, I'm going to use X number of mass for this particular part. And instead, the photo timer will select that for you based upon the image receptor exposure. Now, that is only adequate, or let's say accurate, that's a better word, when that flesh, whatever you're trying to penetrate with your x-ray, is directly over the photodetector. So we'll talk more about that in just a little bit. But the thing is, anytime you use a phototimer, you give up control of time. Think of that x-ray circuit. In the upper left side, you see a little rectangular box that says timer in there. This is one of the timers. So when you set a manual technique, you're telling it, I want it 1/10 at so much, and at 1/10 of a second, it's going to terminate. When you select the AEC, it's going to terminate when it reaches that predetermined amount of exposure that's already been programmed into it. Okay, it'll either that, or it'll hit when ionization occurs inside that chamber, and I'll explain that in just a second. We do become very dependent upon phototimers, and I think you'll see that there's probably people out there that couldn't x-ray somebody without a phototimer. That's not something that I desire for you. I think that as a technologist, if the phototimers break, you ought to be able to just rock on without them. So that's why Mr. Fossey and myself work so hard on you guys when it comes to setting technique in here. It is probably, I say this over and over, probably one of the hardest things to learn is to set technique, especially your mass. If you know your KV range, your half of the battle's won, but then figuring out your mass is a whole nother kettle of fish, and it depends on where you're at. So, your positioning is crucial. You hear that? I'll say it again. Whatever you put over the active photo cell is what your radiograph will be. It's going to be photo time is going to be exposed to the proper density for that tissue. It's up to you to put the right tissue over the radiograph. Alrighty. So let's talk about something else that you may or may not have noticed, and that's the density controls. Density controls are the +1, +2, +3, I think you may even go up to +4, or -1, 2, 3, 4 on the density. And what that just does, that just tells the computer, hey, we're going to wait a particular length of time to terminate this exposure because I'm phototiming you, but for whatever reason, I think it's going to take more time, and which will be more mass. So I'm going to go +1 on my density. And if we do that, we're going to increase our density amount by about 25%, or that's going to be the exposure, which should increase our density. But that all depends on the patient, of course. That's sort of out of our control. So when you leave it at 0, it's expecting the normal configuration, normal programming, normal amount of exposure. If you, for whatever reason, go up to +1, it's going to say, well, then I need to increase that. And it'll wait 25%. As we know, 25% increase in exposure is really not going to make much of a density difference. So if you're going to go plus anything, you're going to have to go +2 or more, right? Because I'm talking about mass. And if we make a 25% increase in our mass, that's a pretty minimal change. We're going to need to go at least +2 to make any kind of difference. We have to get past that 30% increase in mass. I'm not telling you anything you don't know, but I'm trying to tie it all to this new stuff that we're talking about. Everybody cool? Well, you can't answer me, so I'm going to assume that you indeed acknowledge that you are cool. All right. Don't worry about doing this for part thickness, although some people do that. But part thickness is really kind of taken out of the equation because that's what the AEC does. It's going to phototime based upon the amount of exposure that that photocell receives, and it really doesn't know what's above it, and it doesn't care. It just says, oh, I'm expecting this many volts, and when it gets it, it terminates. So just use the density controls, watch the text, and figure out what they're doing, and then use the density controls somewhat when they do. And then here's the other thing: if you do compensate for thickness because of density, you're probably going to be okay anyhow. I mean, because it is relatively foolproof to use these things, but make sure that you only use them whenever it's appropriate. All right. Now we haven't talked a lot about technique charts in here. I would refer you to other chapters in this book where it talks about the Mayo Clinic system and the fixed KV and the variable mass and all that sort of thing. There's also a fixed mass variable KV. And we will discuss some pieces of that in our next class period, which will be Thursday coming up. Thursday the 6th, no, yeah, Wednesday the 15th, right? Monday was, yeah, Wednesday the 15th, tax day. So we'll start getting into that, and I'll explain that further. But using essentially using a phototimer as a technique chart, what you're using is anatomically programmed radiography. You press the button that says chest, you go PA, you go landscape, you go normal patient, and it sets all of the technique for you. That is, it'll automatically turn on the top 2 photocells. It'll set your technique, and it'll say it's on the wall bucky. That's the configuration normally, and then you make whatever changes you need to. You're going to do a chest x-ray and they're laying down or whatever, and then you give the patient their breathing instructions and you make the exposure. That's anatomically programmed radiography. If you said abdomen, it's going to default to the table and turn on the top 2 photocells, most likely the ones that are behind the left and right kidneys. Maybe it'll turn on the third one again. It just depends on how the system's put together. But you'll be able to tell that before you use it, because the ones that are active will be lit up. Okay, so that'll take care of, it'll set your right KV, and then the photo timer itself will adjust your mass based upon the amount of exposure that it receives, which I'll say again is how much voltage is actually going to be induced to flow through those little photocells. So, good positioning skills. That's the key. Center on the center. Make sure that you position the patient, whatever part of the patient you're trying to penetrate, properly over the photocell that you've activated. So let's pretend you're going to do an AP abdomen, and you go ahead and you press KUB or whatever it says there, AP supine abdomen. You put the patient down on the table, and at some point somebody changes it from the table bucky to the wall bucky. You give the patient the breathing instructions, you make the exposure. Your active photocells are in the wall bucky, but you actually have a patient and radiation source pointed towards the table bucky. Think about what's going to happen. 3, 2, 1. Your image will be overexposed, because the active photocells, i.e. the ones in the wall, are not receiving any exposure at all, and they will continue to wait for exposure while the X-ray tube is shooting X-ray straight down into inactive photocells. So you got to make sure you use the right ones. Is positioning skills. Are you with me? Make sure that you are. Good, solid positioning skills. That means I expect to see you in the lab practicing more. Yeah, I'm nagging. You need to be in the lab more. You need to be practicing more. You want your grade to go up, go in that lab. That's where it's going to be made at. All right. Okay, let's talk about this issue. I described a couple of scenarios back where I said that you've got the wrong set of photocells activated. It's pointing at the table, and the photocells are active in the wall bucky. That will cause that exposure to run until it terminates through tube overload. Well, the federal government has something to say about that. They don't want you running it out to tube overload and overexposing your patient. There's a really good story I could tell you at this point, but I know you don't want to hear it. Anyway, when you expose somebody using a phototimer, this is a federal requirement. The backup time has to be set at 150% of your expected exposure time. There is, ladies and gentlemen, a backup timer on your control panel. Look for it. And let's say you anticipate it to be a tenth of a second exposure. Then you need to set a backup timer that's going to be 150% of that tenth of a second. All right. So you would say somewhere around 4.4 tenths of a second, rather than a tenth. And I know I'm fudging with the math there, but that's what that requires of you. So that needs to be changed between each patient. I will also tell you that I know that it's never touched, and then if you find the backup timer, it's probably going to be set at whatever the max is. But this is what the feds say, and this is what you're going to need to know for your test. 150% of the expected time. Also, that it will terminate at 600 mass, saying that's as high as it'll go as far as the amount of radiation that we give our patient. The other thing is there, and I skipped over it, but it's something I want to talk about, is that minimum response time. Phototimers have to stay on then until they reach some sort of exposure, and most modern AECs, page 510, have a minimum response time around 0.001 seconds. That's probably faster than you can depress and release the button. If we get below that, we can cause some problems. If we do, that problem specifically is probably going to be something known as quantum model, which we touched on before. Reduce your MA. That'll cause that time to increase. Remember, mass is milliamperes times seconds. So if we reduce our MA, that'll cause a longer time, and that should take care of that quantum model and should take care of that minimum response time issue as well. Think about all the tools that you know how to use. MA is milliamperes times time, folks. Just always remember that, and you can manipulate one to change the other. It's easy. So make sure you think about that. I already talked about this term, APR, anatomically programmed radiography. The book discusses it on 511, and I've kind of went down through the technique of that, and you see that, you use that all the time. I don't think that you need me to say anything else. Be conscious, though, that you can override all of these things. If you take a patient history and you're using an APR and you determine, like I said a while ago, you're missing a lung or something like that, then use the radiographer. It's your responsibility to change what the machine set. The machine is a beginning point, and it is not foolproof. Please use your brain and then make adjustments as necessary, because you don't want to overexpose your patients. Manual override is a good thing. It's not a bad thing. That's where creativity and art kind of collide, and gives you, the radiographer, a chance to look like Harry Potter. All right. Also, on your positioning, I will say that I use phototimers just as much as anybody else. I will also say that I always admire those folks who can manually expose patients over and over again. There are people who work who don't use phototimers. Those technologists, you need to hang out with them, because they can tell you how to set technique. They'll teach you how to do that. They look at somebody, and not only do they know the KV, which you know, but they also know the equipment, what room they're in, etc. And that means that they can determine about what mask they need to use. So there's a lot of radiographers that don't use phototimers at all because they don't want to be held to a high standard on positioning. They'll be adequate, but they don't want to have to be perfect. So they'll just look at somebody and set a technique. Oh, I would use 75 at 10 on that, or 75 at 50, or 75 at 12, or whatever. And then they'll shoot that. And if it's wrong, then they know how to go back and fix it. I don't want you. I told you this the other day in class. Your money comes from the fact that you can take a bad radiograph and make it a good one. And if you know what your mass is, you don't have to guess. You can say, oh, my mass was 25 and I expected it to be something else, and then I'll just readjust and do that. Or I needed it to be darker, so I'll double it. Or I needed it to be lighter, so I'll cut it in half. If you know what that mass reading is on a AEC generated image, then you can fix it the second time every time. If you don't, then you are lost. And that's when I told you that one kind of gets under my skin when I see people do that. Every time you phototime a patient and you look at that image, you need to know what that mass was. And it may show up for 10 seconds and then go away. But you need to know what that mass was. Because if it's not a good image, then you can repeat it the second time and do not phototime it the second time, and you'll know exactly what to do. You with me? Well, I'm going to assume that you are. Alrighty. Um, Make sure that positioning, I don't know, say like the fifth time today, positioning is key. Excuse me. Um, get some technique under your belt, get some experience, understand what you're doing, and then you'll be able to go out and start manipulating this. I've told you guys 100 times, Merrill's is a good place to start. It is a cookbook, it's a recipe, and then you take your critical thinking, put it together with that knowledge, and you can create some really beautiful radiographs. That's your responsibility. The phototimer is not programmed for every eventuality. None of that equipment is. It takes what's between your ears to make